So welcome back. In the series of optimization concept for C#.NET, let me continue today with one more example. So in this example, I can show you how the C# getter and setter approach, which is giving you the abstract level of getter and setter interface as a part of framework, and how this approach is actually putting penalty on the performance. So I have just did one small example here. I have created one test class, which is my class, name is my class. And inside that, I just put two variables, two attributes. So two variable member I have created. One is name, another is surname. It is just for like one, it is using getter and setter interface, which is provided by framework by default. And the another, which there I will directly assign the value in this variables. Okay, let's move to the main class, main method where I am just using this, right? Calling it and using it. So smartwatch I already created in, like, you have to know that how do you create. So after a stop, like, I'm just restarting it, and then what I'm doing here is I'm just setting value. If you remember this value, by using the interface given as a setter, right? So it will call eventually invoke the setter method provided by framework. Okay, and so I've just calculated the time for this action by this action, and I have just printed here that time. Then again, like, I have restarted my stopwatch, and then doing the another operation where I'm pushing the value, assigning value to surname. But what is the difference here? This surname variable is not using default interface of setter and getter provided by this C#.NET framework. So this is the, and now let's check the time. Okay, what is the difference and which one is better? So it's a live example for all of us. So okay, so if you see here, direct assign is taking this much time, but using property it is taking this much tick count. See the difference, how big is the difference, right? So these kind of optimization usually not done by, if you are not doing in your C#.NET code, your code will not perform well. Now why is this? And what is the requirement and how to avoid it, right? These things are possibly the key understanding when you understand that how abstraction is created. See, like, if you are experienced in the industry, then you know that creation of abstraction to achieve any implementation at generic level, at the level where you can work, your implementation will work for multi-platform or multi different environment. You need to go up and up in abstraction level, and as you going up, you are actually putting some performance hit. Now which one is better and which one is not better, it depends on your performance requirement. If you are very particular about your performance, you don't want to put any kind of latency, any kind of like time lag, then you should think about these kind of micro level, right? Because in that scenario, this every bit of second is important for you, right? So these kind of improvement, if you will do, probably you might have you might improve the lot many things. Okay, one more thing is, it may be the debug. So whatever the testing you are doing, please do it in release, not in debug. Okay, so debug will not give you the real picture. So after, you just try to release also, and if you will see that release is also providing such kind of big gap, then definitely you will try to implement such things. And as much as possible, always think on that, right? This is what my suggestion here. It is a quick suggestion, but I think this is meaningful for you, and please take care in your implementation. Thank you. Let me come with this next improvement. One good thing, one optimization of today is, earlier, if you remember, I told some time back that container, try to use as much as possible a static data structure instead of dynamic data structure, because dynamic data structure has something over, something as a penalty of performance. Why? One example is that dynamic container is always giving you runtime, capacity enhancement, right? They can automatically create new bigger size of container, and they will copy from the older container to new container, and then they can clean the older container. But these all things happening without penalty is actually not a right thing to understand, right? As an architect or as a senior programmer, please understand that this will only possible if you can put some penalty. Like, penalty is like, you have to create new bigger size container, copy it from older one to new one, and then clean the older one, and then you have again enough space to accommodate new elements. Now what is that, how these are growing, like how much percentage they will grow, it depends on like implementation to implementation, but usually in double size, right? Every time a container needs to expand, that container is always making double to there himself, right? That is the way we have implemented our container. So next thing is, which is one approach here is to almost mimic the static like data structure to give the initial capacity of initial size to this container, so that, and that size must be sufficient enough to avoid any reallocation in later stage, right? And let's try to learn the what I would say. Okay, so let's try to learn these things. Okay, so in my opinion, like let's say list int 32 and li, this is equal to new list int 32 and this is one. Okay, why it is saying that? Because this is okay, no issue, L1. Okay, what is that? A local variable function L1 is already defined. Okay, L new, L1 new. Okay, and then similarly just create L2 new, and here you have to keep the 10,000. Okay, just do this. Okay, now sw dot restart. Okay, so sw dot restart, and yeah, now so for int I is equal to 0, I is less than 1 lakh plus I, and many of you know that L1 new and dash add. Okay, so this is something like I is already defined, so remove it. I mean type declaration you should remove from here, and then just check sw dot stop and this one. Okay, and then console dot write line, and I will say that the tick count is okay, and that's it, not this one, that's it. Okay, so this is one thing. So just run it once again and check the tick count. I mean, if you so direct assign, I don't know, using property, I don't think I'm getting any value here. So list dot add I L1 days, and this is like stop. I don't know. Okay, and this is like okay, so yeah, this is wrong. Okay, so don't do this. Now you can see that okay, so the tick count is something 6998. Okay, now what if same thing you will do with which one, in this one, right? So another way is I have just created of that size, maybe 5 more, and then if you do it, let's check how much, and this is your 2222, just do like 2222. Okay, so yeah, and if I do it, I can see that almost even in the release it is almost like giving you much better value, right? This ticks is almost in second, I don't know, but yeah, it seems so. So this is the another optimization which earlier we have not done, but now I identified that this is also another optimization in .NET. Even the similar approach also we should consider in C++ container. So it is same as C++ container. In C++ container also, if you want to avoid dynamic resization of your container, probably it is better choice to initialize your container size beforehand, right? So that, I mean, resizing and copying cost would be avoided. That is the optimization thing here. Okay. Okay, let's meet again for another optimization. Thank you.